Crop productivity. The term productivity regarded as the ratio of the input to output, which are related to the land, labor, capital, and our all resources which are employed in agriculture. Crop productivity is the quantitative measure of crop yield in given measured area of field. According to Jasbir Singh in 1972, productivity is the degree of which the economic, cultural, technical, and organizational variables are able to exploit the biotic resources of the area for agriculture production. Type of organic waste. There are 4 types of the organic waste. First one is domestic or household waste. Second is animal and human waste. Third is agriculture residue, and fourth is commercially produced organic waste. Organic waste available for recycling. Under the group, plant waste include crop residue and kitchen wastage, and animal wastage contain animal dung and urine and poultry excreta. Other wastage are biogas slurry, sewage sludge, agro-industry, sugar and distillery wastage. First one is domestic or household waste. Domestic or household waste include the food scraps, which may be cooked or uncooked food, and it also include garden wastage, which have grass cutting or trimming from bushes and hedges. Domestic or household waste contain higher organic content than other wastage. Second one is commercially produced organic waste. It generated in institutional buildings such as school, hostels, and restaurant. The quantities of waste here are much higher than other wastage. Third one is animal and human waste. Animal and human waste contain raw sewage contain bacteria and pathogens that cause serious illness and disease. Animal residue is commonly used as source of fertilizer. Agriculture residue. Agriculture residue are the leftover material of crop after the harvesting or processing of the crop. Agriculture waste include rice straw, wheat straw, rice husk, maize stalk, and foliage. Application for this residue ranging from simple combustion on an open fire to complex energy production process that use this waste as a fuel stock. Agriculture recycling of organic agriculture waste and their associated benefit and risk are by Sharma et al. 2017. Organic agriculture waste can be recycled by the vermicomposting, composting, and anaerobic digestion, which are used in the agriculture. Benefit of recycling of organic agriculture waste are: it improves soil fertility and crop productivity by improving soil structure and nutritional status of the soil, and also mitigate the greenhouse gas emission by proper use of industrial and other wastage. Organic agriculture waste is most important alternative to chemical fertilizer, reduce amount of landfills waste, and enhance conservation of land resources. And other risks associated with the recycling of organic agriculture waste are: heavy metal like the lead, mercury, chromium, cobalt, nickel, etc., which cause the contaminate in the food chain, and these heavy metal cause disease in human being like skin allergy, cancer, and central nervous system. Method of recycling of organic waste: in situ recycling, raising of green manuring crop, growing green manuring crop in the field and incorporating the green manuring crop in same field, generally 45 to 60 days after the sowing. In this condition, green manuring crop contain highest amount of the organic matter, humus. It accumulates 100 kg nitrogen per hectare. Forage or leguminous crop are generally used for the green manuring crop. and it is the most important source of the nitrogen and organic matter. In rice-based cropping system, Dhecha sesbane species is highly suitable as green manuring crop for waterlogging area, whereas sun hemp Crotoluria juncea is suitable for rain-fed areas. Sesbane aculeata crop accumulate 133 kg nitrogen per hectare. Sesbane rostrata accumulate 95 kg nitrogen per hectare. Crotoluria juncea accumulate 134 kg nitrogen per hectare. Mulching of organic residue. Biomulch accelerate the decomposition of the crop residue and enhance nutrient cycling, improve the soil organic matter content, the water and nutrient retention in soil. Organic matter is a source of both macro and micronutrients. Second one is situ recycling composting. Composting is the process which convert the organic residue of plant and animal origin into the organic matter, which lower down the same ratio of the organic residue by the aerobic and anaerobic microorganism. It improves the physico-chemical and biological property of the soil. These microorganisms convert the complex biological material like lignin, cellulose, hemicellulose, polysaccharide, protein, etc. into simple available nutrients. Elemental analysis of crop residue by Dubey et al. 2015. Arhar stock contain highest amount of the carbon percentage, which are 53.30, and bagages contain higher amount of the hydrogen percentage, which 6.10%, and groundnut shells contain higher nitrogen 1.60%, and groundnut shells have a high phosphorus percentage 0.12%, and potassium is high found in rice straw, which are 2.50%, and calcium is highest in bagages, which are 0.14%, and magnesium is highest in rice straw, which 0.53%. Composting by involving earthworm. Compost preparing using earthworm called vermicompost. Most important earthworm are Icenia foetida, Feritema elongata, and Hydrolus ingeni. Nitrogen in vermicompost, nitrogen is found is 0.6 to 1.2% nitrogen, 0.13 to 0.22% phosphorus, and 0.4 to 0.7% potassium. Vermicompost is rich source of the nitrogen, phosphorus, potassium, humic acid, plant growth regulators, nitrogen fixation in phosphate solubilizing bacteria, vitamins, antibiotics, enzyme, etc. And it contains a high concentration of the nitrate nitrogen and lower concentration of the ammonium nitrogen. Composition of nutrient element of vermicompost and leaf compost by Erancon et al. In 2005. Cow manure vermicompost contain higher nitrogen percentage, which are 1.9%, and phosphorus is also high in cow manure vermicompost, which 4.7%, and potassium is highest percent is found in food waste vermicompost, and calcium is highest found in yard waste compost, which are 89,207 microgram per gram compost, and magnesium is highest found in yard waste compost, which are 21,229 microgram per gram compost, and sulfur is highest found in biosolid compost, which are 6,291 microgram per gram compost, and zinc is highest found in biosolid compost, which are 1,281 microgram per gram compost. Effect of different organics on soil health. In physical property, bulk density is lowest found in treatment 3 when apply 100% nitrogen as FIM, and highest bulk density is found in Treatment 1, control and treatment 2, 100% nitrogen H urea, which are 1.42 megagram per meter cube, and highest water holding capacity is found in treatment 4, 100% nitrogen H vermicompost, and lowest water holding capacity is found in treatment 1 and treatment 2, which are control and 100% nitrogen H urea, which are 35.8% and 35.7% respectively. And in chemical properties, organic carbon percentage highest found in treatment 7, 75% nitrogen H FIM, 75% nitrogen H vermicompost plus azospirillum, which are 0.78%. And the lowest organic carbon percentage found in treatment 1 control, which are 0.28%, and highest available nitrogen in kilogram per kg per hectare is found in treatment 7, 25% nitrogen H vermicompost plus azospirillum, which are 253 kg nitrogen per hectare. And in biological property, highest bacterial colony forming unit per gram is found in treatment 7, 75% nitrogen vermicompost with azospirillum, which are 393 colony forming unit per gram. And fungi is highest found in treatment 7, 75% nitrogen H vermicompost plus azospirillum, which are 28 colony forming unit per gram, by Kanan et al. In 2005. Improvement of the physico-chemical and biological property is they are affected by compost treatment in corn crop. Treatment for 120 ton compost per hectare gives the lowest bulk density, which are 0.91, and in control gives 1.182, and organic matter percentage highest in treatment for 120 ton compost per hectare, which are 9.46, and under control 5.36%. And highest nitrate in ppm is found in 120 ton compost per hectare, which are 16.01 ppm, and the lowest nitrate in control. And highest phosphorus in ppm is found in 120 ton compost per hectare, which are 76.65 ppm, and lowest found in control. And highest potassium in ppm found in 120 ton compost per hectare, which are 18.70 ppm, and lowest in control. And highest calcium in ppm is found in 5492.18 ppm in 120 ton compost per hectare. And highest magnesium percentage magnesium in ppm also found in the 120 ton compost per hectare, and lowest in control, by Muhammad et al. In 2004. The effect of biogas slurry on the soil properties after harvesting of baby corn, by Malav et al. In 2015. Lowest bulk density is found in 100% biogas slurry, which are 1.39 gram per cc, and highest porosity is found in 100% biogas slurry, which are 47.54%, and highest organic carbon percentage found in 100% biogas slurry, which are 0.48%, and the highest available nitrogen kg per hectare is found in 100% biogas slurry, which are 245 kg per hectare. Highest, and there is no more difference between phosphorus and potassium in compared to other treatment. Effect of vermicompost and NPK on the chemical properties of soil after harvesting of the bean. In clay loam soil, harvesting of the bean, treatment 1 is control, treatment 2 is the RDF 20:80:40 kg per hectare, and treatment 3 is recommended dose of the vermicompost 5 ton per hectare, and treatment 4 is 50% vermicompost plus 50% NPK. Treatment 4, in clay loam soil, treatment 3 gives highest organic carbon percent, which are 8.52, and treatment 4 less than treatment 3, which are 3.17%, and the highest nitrogen is found in treatment 3, which are 207 kg per hectare, and treatment 4 is lower than treatment 3, which 201 kg per hectare. Highest phosphorus kg per hectare is found in treatment 3, which are 16.8 kg per hectare, and treatment 4 gives 15.3 kg phosphorus per hectare. And highest potassium is found in 317 kg per hectare, and treatment 4 given to 67 kg potassium per hectare. And calcium percentage also high in treatment 3, 3.07%, and treatment 4 give 2.69%. And in sandy loam soil, treatment 3 gives 9.42% organic carbon percent, and treatment 4 give 5.06% organic carbon. And nitrogen in kg per hectare found in treatment 3, which are 200 kg nitrogen per hectare, and treatment 4 give 193 kg nitrogen per hectare, which are less than treatment 3. And phosphorus also high in treatment 3, which are 14.1 kg phosphorus per hectare, and treatment 4 give 12.2 kg per hectare. And potassium kg per hectare high in treatment 3, which are 290 kg potassium per hectare, and treatment 4 gives 260 kg potassium per hectare. And calcium is also high in treatment 3, which are 2.97%, and treatment 4 give 2.08% calcium. Effect of vermicompost and NPK on biological property of soil after harvesting of bean. Treatment 1 is control. Treatment 2 is RDF to 20:80 to 40 kg per hectare. Treatment 3 is recommended dose of the vermicompost, which are 5 ton per hectare. And treatment 4 50% vermicompost plus 50% NPK. In clay loam soil, treatment 3 have highest bacteria, which are 50.4 colony forming unit into 10 की power 6 gram per gram. And fungi is also high, which are the 42.1 colony forming unit into 10 की power 4 per gram soil. And treatment and actinomycete is also high in treatment 3, which are 10.7 colony forming unit into 10 की power 5 per gram. And total microbial population is high in 15.8 in treatment 3, which are colony forming unit into 10 की power 6 per gram. And microbial property also highest in treatment 3. And in sandy loam soil, treatment 3 gives 36.2 colony forming unit into 10 की power 6 per gram bacteria. And fungi is found in 35.1 colony forming unit into 10 की power 4 per gram. And actinomycetes, which are 7.5 colony forming unit into 10 की power 5 per gram. And total microbial population 37.2 colony forming unit into 10 की power 6 per gram. And microbial activity is also highest in treatment 3 in sandy loam soil by the Manivannan et al. In 2009. Yield and nutrient uptake by wheat under inorganic fertilization and FIM treatment. Highest grain yield is found in 100% RDF plus FIM 10 ton per hectare, which are 5.9 megagram per hectare. And ISRO yield also highest in 100% RDF plus FIM 10 ton per hectare, which are 5.8 megagram per hectare. Then control and nutrient uptake is also high in 100% RDF plus FIM 10 ton per hectare, which are 105.8 kg per hectare. And phosphorus is 17.8 kg per hectare, also high in 100% RDF plus FIM 10 ton per hectare. And potassium uptake also highest in 100% RDF plus FIM 10 ton per hectare, which are 29.3 kg potassium per hectare by Meena et al. 2018. Studies of plant yield improvement by compost amendment. In test plant corn sewage sludge compost at the rate of 150 kg nitrogen per hectare gives 12% high dry matter yield than without compost application by Verman et al. In 2005. In wheat test plant, compost sugarcane bagages at the rate of 15 megagram per hectare gives 23% higher grain yield by Berjager et al. 2002. In sorghum plant, composted household refuse, animal manure and crop residue at the rate of 10 megagram per hectare gives 238% high grain yield by Udrego et al. In 2001. In tomato, chicken manure compost at the rate of 19 ton per hectare at vermicompost at the rate 30 ton per hectare gives 74% higher yield by Wang et al. In 2017. Future research needs in recycling of organic waste. Research should be based on beneficial effect of recycling of organic waste on soil health and environment for public awareness, and also should focus on availability of organic waste, economic viability and profitability of production system, development of modern compost method, better utilization of microbes for decomposition and enrichment of compost and vermicompost with nutrient. And research should be based on easy decomposition of cellulose, hemicellulose, lignin, polysaccharide containing organic waste. Identification and exploitation of indigenous microbial strains for decomposition. More research should be focused on utilization of agro-industrial waste for crop cultivation. Studies on the potential risk associated with recycling of contaminated urban waste with heavy metal, plasticizers and surfactant accumulation on soil health. Conclusion. Bioconversion of organic waste to utilize their ample nutrient content for upgradation of soil quality and crop productivity. Use of organic manure provide nutrient to the soil, act as soil conditioner and effective replacement of inorganic fertilizers. It also conserve energy, reduce pollution and improve fertilizer use efficiency. It maintains soil health by improvement in soil physical, chemical and biological properties.